most likely development teams are going to have to go to either a security group within their organization or an outside agency to get help with that. Okay, so I think we kind of have the background information we need to understand why SDL Agile is going to be important. The main thing that Microsoft was trying to address with SDL Agile was the problem of not being able to fit all the security activities within a single iteration. Their solution was to basically reorganize security activities into requirements and allow the completion of them to span multiple sprints. And as we'll see, we have usually about 6 months in which every single requirement will have to be eventually completed. Now, one great thing about this approach is we can actually take these requirements and treat them just like user stories. We can basically create little index cards, write out what that security activity is, and move it along in our board as if it was, just any other feature that we're going to implement. Now, there are some drawbacks to using SDL Agile. For example, we're basically going to release software. We're going to have functional software at the end of every single iteration. That means we could potentially release it to customers or to the web or that sort of thing. And if we do that before the 6 months period is up, that means we could release software without it going completely through the SDL. Now, Microsoft actually calls out this fact in their SDL document, and basically their reasoning is we have to have a trade-off between security, feature development, and the speed of release. So basically, we're going to have to make a compromise in Agile development in order to kind of stay true to the ideas. Now, one additional thing to consider is, since we're going to use these SDL Agile requirements as user stories, we can actually talk to the customer about which of these are important to them. So if we have some sort of activity that we think is really important, we can bring it to the customer and say, we think this activity is going to take X amount of time, it's really important. Can we prioritize this security activity above this other feature that you don't care as much about? So it really improves the communication between the development team and the customer and allows them to make decisions about security. The SDL Agile requirements are broken up into 3 categories. They're listed on this slide, but I'm going to go to them in detail. The 3 categories are every sprint, bucket, and one-time requirements. And why don't we go ahead and dig into that? So the every sprint requirements are basically mandatory items that we're going to do every single time we write software. So every single iteration, there's certain things we're going to do. Some examples of some of those things we're going to actually follow secure coding standards. So this isn't something that should take extra time within a development team. We should simply know what those security standards are, be trained against the security standards, and the team should have experience writing correctly parameterized SQL queries or using the Microsoft Web Protection Library to prevent cross-site scripting, that sort of thing. We'll do other things like identify some sort of privacy or security advisor to help us along either completing security activities or understanding which security activities are important to us. And we'll actually do things like update the threat model for each user story. One note on this one, that doesn't mean we're going to create a threat model from scratch or anything like that every single sprint, and it also doesn't mean we're going to create an in-depth threat model. Basically, one of our other requirements will be to take care of those activities, and we're going to just update the threat model for a particular user story. Bucket requirements are kind of like just a miscellaneous set of other requirements that don't fit anywhere else. We actually have the opportunity to, as the development team, to choose which ones are important and when we'd like to do them. We do have a 6-month period where we have to get every single one of them done, but we can choose to do pen testing 5 months down the road versus 1 month down the road, that sort of thing. Now, each of the bucket requirements are categorized into 3 different tasks. There's security verification tasks, which really focus on things like running fuzzing tools or doing pen testing or doing code review, that sort of thing. We have design review tasks, which are things like looking at the application, how it works, what type of data it has in it, whether we have any sort of privacy concerns, and also the activity of creating an in-depth threat model is one of the items in the design review tasks. For response planning tasks, we'll do things like determining what's an acceptable level of risk in the application, so defining a security/privacy bug bar. And we'll do things like creating an operational security guide or deployment guide. So when we do release it, within a data center to the customers, we'll give them guidance about how to do that securely. The requirements as far as what types of, or how many bucket requirements we need to choose each sprint is we will choose at least one task from each of these categories, so one security, one design, and one response planning task. We can choose more than that, but we need at least one of those at the minimum. For one-time requirements, these are things that usually just means it doesn't make sense to repeat. There are things like creating a bug tracking system. Obviously, once you have a bug tracking system up and running, you don't really need to do it again. And then another item on here is creating a baseline threat model. So kind of a starting point for that bucket task of creating an in-depth threat model. A lot of times, let's see. Okay, let's find this slide. You do have to complete all the one-time tasks within 6 months. There's other specific guidelines as far as deadlines for each activity. We're actually going to get to that in 2 more slides, so I'll kind of talk about that more then. In the SDL guidance documentation, there's actually some appendices where it talks about what the different security activities are for one-time, every sprint, and bucket requirements. This one shows kind of the bucket requirements and shows the different activities that are involved, whether they're required or recommended, and actually has a table showing if you're creating an online service or some sort of managed code or native code, whether it even applies, whether it makes sense to do. This is the one-time requirements, and I mentioned that there's specific deadlines for these activities. In the center column, there's things like creating a bug tracking system. It has a maximum deadline of 3 months. While creating a security response plan might be 6 months down the road that you have to complete. Okay, final security review. So both the SDL Classic, or the Classic SDL, and the SDL Agile have this concept of a final security review. It's basically an opportunity to look back at the previous development iteration or on Classic SDL, the whole waterfall approach, and decide, did we complete all the activities that we should have? In a waterfall approach, the Classic SDL, this is a process that can take quite a bit of time. In the SDL documentation, I believe it says it could take anywhere from a couple days to a couple months. And that's definitely not something that'll work for SDL Agile. What they ended up doing for the final security review is making a simple checklist. And all we do is simply run through a checklist, make sure that we haven't exceeded any deadlines, make sure we've selected an appropriate number of bucket requirements, make sure our application is within our acceptable level of risk, our tolerance levels, and it's actually a really quick process. It takes very little time. Okay, so this is my fun animation that I'm going to show you in a second. Basically, I wanted to kind of mock up what a board might look like for a sprint when we're treating SDL Agile requirements as user stories. So we have our typical backlog up on the top left, and these are just our features that we're going to implement in the application at some point. Then we have our one-time and bucket requirements on the bottom left, and we basically have index cards just like our user stories. And really, you can treat them all the same. Just stick them on the Agile, on the board that you're using as your central documentation. Go ahead and plan out your first 3 sprints, for example. And add your bucket requirements, add your one-time requirements, and just move them along with every single other requirement. So it's really in line with what teams are already doing, and that should make it a lot easier to adopt SDL Agile requirements and track them to completion, that sort of thing. Okay, 10 minutes. As far as making SDL Agile more manageable, there's a lot of things that we can really do to kind of reduce the effort that team members need to do to complete those requirements. So in Agile software environments, we really have to focus on creating features, getting user stories completed. We can't spend a lot of time, a lot of manual processes getting security activities completed. So one really big thing that we're going to do is we're going to use as much tools and automation as possible to help us along. Now, before we can actually use these tools and automation, we really have to understand our goals and understand how to use some of these tools and understand secure coding standards, that sort of thing. So things like documented secure coding standards, cryptography standards, information about how to handle certain types of data is going to be absolutely important. And then we'll do security training against those standards and security training to help developers understand how to complete different activities or tasks. In addition, a lot of Agile teams use continuous integration servers to basically, in some cases, make sure that a user feature or user story, when it's completed, it can be verified that it works in the target environment and it can be quote unquote done. Continuous integration environments, in case anyone's not familiar, is basically an environment where the machine constantly pulls code from the SVN repository or CVS repository and goes ahead and builds it, runs unit tests, runs maybe functional tests nightly or weekly or something like that, and then deploys the software actually out to a server to make sure that it runs and everything. Now, since we're already doing all this automated, kind of automated unit tests and functional tests and that sort of thing, we can actually loop in a lot of tools with this process too. So we can loop in things like cat.net, which is a code analysis tool for cross-site scripting and SQL injection. We can loop in commercial source code review tools. We can schedule penetration testing activities, maybe nightly or weekly, that sort of thing. And basically kick out a report after we're done. Now, what we would do is we'd take this report and basically if it finds any issues, maybe we'll say if it finds any high-risk issues, it reports back to the team that the software doesn't build, which is kind of the developers signaled to stop what they're doing and then fix the code that they're working on. So we can kind of integrate those tools together. Yesterday, there's a presentation from some Microsoft folks about tools we can use. They went through a Team Foundation server and an Agile plus SDL process template that's really helpful, so we can use those to track tasks. And then the other thing I wanted to point out is we're not going to create any extra documentation or artifacts that our teams need to generate in order to accomplish SDL Agile. Okay, so I mentioned that tools are a great way to reduce that effort, and I have 5 minutes left. I'm actually going to go ahead and skip to a demo because that's a lot more fun. So, has anyone heard of the Web Protection Library or used the anti-XSS library before? Anyone? Okay. I'm going to quickly, in 5 minutes, see if I can demonstrate using the Web Protection Library, the encoder, the sanitizer, and actually the security runtime engine. Basically, these are libraries that we can use to prevent cross-site scripting attacks and basically kind of reduce that effort as far as either writing our own code to properly handle those situations or anything like that. So what I actually have here is just a real simple web page with a label. We have, come on, there we go. All we're doing is we're taking a query string parameter called payload and just loading it right into the label. I do have event validation turned off so that I can demonstrate this. But basically, we created a situation where we have a cross-site scripting vulnerability in our application. So first, I'm going to kind of demonstrate just a simple alert box coming up from a query parameter. And then I'll show you how we can use the Web Protection Library to prevent cross-site scripting. So if this were real, we wouldn't just do an alert box. We would do something more evil, steal your credentials, something like that. But this just kind of demonstrates that we have this content in red up here, and we have an alert box coming up. Now, with the Web Protection Library, we have an encoder function right here that has a number of ways that we can encode and handle data. So we do things like HTML encode, JavaScript encode, I believe there's a CSS encode, and a variety of other things based on the situation that we're redisplaying that untrusted user data. Now in this case, all we have to do is take our request parameter, run it through the HTML encode method of the encoder class, and load it into the label control. And we will see that, let me refresh this. We'll see that it doesn't execute that alert box or come up with that red heading, that sort of thing. And if we go ahead and look at the source, we have all these correctly encoded HTML entities and that sort of thing to prevent it from executing. Now, another feature we have is the sanitizer. This is a library we can use to safely accept some HTML. I kind of say that with a caveat that it might not be completely safe. It seems to be, but you never know. So in this case, we're going to go ahead and run this, and we want that red heading to show up, but we don't want the alert box. So if we go ahead and use the sanitizer library,